Hello, everybody. Welcome to today's video lecture, and we continue covering the cardiovascular system, blood vessels, and circulation. So this is the second video, and in this video, we will concentrate on major blood vessels that we need to know, right? So let's go ahead and begin. So let's review anatomy of the aorta first. I'm going to pick up my pen. Right there. So over here you would have the heart, right? So that would be a heart, and aorta begins at the left ventricle. So left ventricle. Remember, atria are receiving chambers. Let me just draw it for you very quickly. If you kind of imagine this is the heart is. It is hard, but so here you have your upper chambers, right, that are atria. Now atria are receiving chambers, so the blood will be received by atria. So this is a septum, and then from atria blood moves to ventricles, and this is your left. This is the left side, right? Now from a left ventricle, your blood will go through the blood vessels, the biggest blood vessel in your body, that is your aorta. So the blood will go right there to the aorta. Oh my goodness, hold on. This is just horrible stuff. So let's do it one more time. Okay. So here's the heart, right? So here's the septum. So here's my, oh, this is even gonna be worse. So this is left. So left atria, left ventricle, and then this blood vessel here, that is aorta, right there. So let's go to aorta, down, and you will have some, not some, but 3 blood vessels that branch from aortic arch. Oh my goodness, sorry for these drawings, but let's look at a picture. So it's way better picture. So that's the beginning of your aorta. You have aortic valve, right? And then aorta kind of goes up, and it's called ascending aorta. Then it makes this U-turn called aortic arch, and then it goes down, and we call it descending aorta. Now, descending aorta, then in your thoracic cavity will be thoracic aorta. And when it passes through diaphragm, it becomes abdominal aorta. Right, so now, so aorta gonna carry oxygenated blood to every single organ and tissue and cell of your body, right? And it will have many branches. I think we have like about 100 branches from aorta. But the first 2 branches right here will be right and left coronary arteries. Now, coronary arteries bring blood to your heart itself, to the muscle of your heart, to a myocardium and epicardium of the heart. Then from aortic arch, you will have 3 branches, 1, 2, 3, and those branches will bring blood to your neck, head, and upper lids. So your arms, forearms, and your hands. All right, so so the first one will be Brachiocephalic Artery, then left common carotid and left subclavian. Now, a brachiocephalic artery, sometimes we call it trunk, because that's a pretty short blood vessel, and very soon it will bifurcate, or it will be branched into 2 vessels, right subclavian and right common carotid. So instead of having 4, right? So this 4, look, they have the same name. The only difference between them is right and left. So we have right subclavian, left subclavian, right common carotid, left common carotid. The difference is that on the right side of your body, you begin flow of blood with brachiocephalic artery, right? Now, subclavian arteries bring blood to your arms and forearms and hands, right, upper extremities, and common carotid arteries will bring blood to your neck, to your head, and to your brain, right? Okay, so that's aorta. So over here, you can see our brachiocephalic artery. That here it's actually called brachiocephalic trunk. That is fine because that's a short artery in anatomy called trunk. And here we have our two branches. So we're on the right side over here. I know we're on the right side because you have brachiocephalic artery or trunk and you do not have it on the left side. But you have subclavian, right subclavian. So everywhere over here, we will have right blood vessels. So we have right subclavian and right common carotid. Now when common carotid moves up, right, and somewhere at a level of your larynx, this is a thyroid cartilage of the larynx, you call it Adam's apple, right? So somewhere at this level, it's gonna split again. And now it's split into external carotid. Oh, it's not this one, external carotid and internal carotid. Now, internal carotid carries blood to the brain, so it enters this cranial cavity, and external carotid brings blood to your face, to your head, muscles and skin of your face and head. Right, there is another branch right here that also carry blood to your brain, and this is called vertebral artery. And then we have our subclavian, right? So I think we cover all the blood vessels that are labeled on this diagram. Now those are blood vessels of your brain. So some of them already familiar. So here's our vertebral arteries, right? So that's vertebral artery. And this is our internal carotid artery. And you see how vertebral artery form this basilar artery. And this part of the brain is pons. This is the medulla. So where we have these pons, we have basilar artery and internal carotid arteries, and basilar artery forms this structure that called a circle of Willis. So you can see what is important about this diagram is you can see how all these blood vessels kind of connected to each other. They form what we call anastomosis. So there is a lot of connection between different blood vessels, and this is to make sure that if some arteries are blocked, you still have blood flow to the brain, and at least major part of your brain is receives oxygen, right? Because it's very important to receive oxygen, and we want as many connection between blood vessels as possible to prevent a shortage of oxygen to the brain. Right. So for example, if you would have just, let's say, if you would just have internal carotid arteries and there is a blockage over here, then the whole brain would die. But thankfully, we have basilar artery. So basilar artery, look, the blood can still flow through all these connections and supply your brain with oxygen. Now here we need to know vertebral artery, internal carotid arteries, this two, and posterior cerebral artery, middle cerebral artery, and this is anterior cerebral artery. Okay, on this diagram, we can see aortic arch, right? So this is left side, so we have left common carotid, left subclavian. This is our brachiocephalic. and then it branches into right common carotid, right subclavian. And now this subclavian artery moves all the way down towards your hand. And because it's a long blood vessel, it passes through different region of the arm and forearm that actually changes names, right? So over here, when it passes through armpit, the name is axillary, because you know in anatomy this is axillary region. So it became axillary artery. Now it moves in your brachial region, and we call it brachial artery. Then it splits into radial and ulnar artery. Now this is your pollex or your thumb, and we know we have radius that is lateral. So that's why this is a radial artery, and this bone over here is ulnar, so that's going to be ulnar artery. Now this radial and ulnar artery form arches. Oops, I picked up, let me see, I don't want this, I want blue color. All right, so they form these arches. This one is superficial palmar arch, because this is our palmar region. And over there we have deep palmar arch, and we have digital arteries, right? Also another artery over here, we can see this one that is internal thoracic artery, and this is our thoracic aorta. Now, when aorta passes through the diaphragm, it goes through this aortic hiatus opening within the diaphragm. It became abdominal aorta. So this over here and goes all the way down. This is abdominal aorta, and you have very important blood vessel over here that is short blood vessel. And because it's short, we call it trunk. So this blood vessel is celiac trunk. Importance of this blood vessel is that arteries that branch from celiac trunk will supply your digestive organs. So the cephalic trunk quickly is split into 3 blood vessels. So this one is a left gastric artery. Right, that's a left gastric. So it brings blood to the stomach. This one is splenic. So you see it's bring blood to spleen. This is spleen. And this is common hepatic. I'm gonna bring blood to liver, right? Then common hepatic has another branch, and this one is right gastric artery. Right, so this is right gastric. So left gastric and right gastric then have anastomosis between each other, so they supply the stomach. And then common hepatic become a hepatic artery proper. Okay, so on this diagram we need to know celiac trunk. We need to know 3 branches, left gastric, splenic, and common hepatic, and hepatic artery proper, and right gastric artery. So this is where we see our celiac trunk. So here's our, trying to pick up my pen. Here we go. So this is the celiac trunk, right? So this is our left gastric, splenic, common hepatic. Just superior to celiac trunk, we have inferior phrenic artery. So it's bring blood to a diaphragm. So that's structure which here is the diaphragm. And then we have branches, right? So we have we have 2 blood vessels that not paired. So like see, like you have 2 renal arteries, right and left, but this one you have just 1, and this one you have 1, and they kind of coming towards you. And this is called superior mesenteric artery, and this one is inferior mesenteric artery. Superior and inferior mesenteric arteries carry blood to small and large intestine. Right, what else we have? We have renal arteries, this one and that one, and we have, you know, you see lots of branches over here. For example, those arteries, if it's a female, we call it ovarian arteries or testicular arteries in male, or gonadal arteries for, you know, both male and females. We will cover more of these blood vessels during our lab. So right now it's it's preparing for you for your lab, where you will look at way more blood vessels. So this is how much you need to know so far. So inferior phrenic artery, right, celiac trunk, as I already said, we already covered. We have renal. This one is, by the way, suprarenal. So we have a superior mesenteric, inferior mesenteric. And when aorta reaches your pelvis, right? This is a bone, by the way, over here. This is your ilium, and this is the ilium. So when it reaches your pelvis, it splits. It splits into two blood vessels, and it's called common iliac arteries. So we have right and left common iliac arteries. Now we move to the your thigh and leg and foot, right? So here's our, by the way, common iliac, and common iliac will split into this one internal iliac, and this one is external iliac. So far, just remember external iliac, and then external iliac moves down through the femoral region, and it changes name to femoral artery. When it approaches your knee, it's actually moves to the posterior side. So here you can see, and it moves through this opening. It's called adductor hiatus. So instead of being on anterior side, it moves to the posterior side, and it makes sense because you don't want a blood vessel to move across your knee. That's a huge blood vessel, and you have a bone over here, so it's not very protected. But it moves to the back, right, in your popliteal region, and it's became popliteal artery. Right now, the popliteal artery now will give some smaller blood vessels that carry blood to the leg. Now, the first branch over here is anterior tibial artery. So it goes back to the front. So it's right here. That's anterior tibial artery. Another branch will be fibular artery, go to a lateral side. So that's lateral side, away from your midline of the body, and continue down is posterior tibial artery. Then posterior tibial artery is split into medial plantar and lateral plantar, and then we have plantar arch, and we have our over here digital arteries. And anterior tibial form this arcuate artery, and it's gives this dorsal metatarsal arteries on the dorsal side of foot. All right, so let's repeat what we need to know here. External iliac, right? So it's actually, it's exiting a pelvic cavity through the inguinal canal, right? So external iliac became femoral, femoral became popliteal, popliteal split into anterior tibial, fibula, posterior tibial gonna make medial plantar, lateral plantar artery, plantar arch, and digital arteries, and anterior tibial became arcuate artery and dorsal metatarsal arteries. Okay, and now we are collecting blood and gonna bring it back to the heart. here what I try to do, I try to put name of the veins that have the same name as arteries in blue color. And if veins are superficial, they have different names and they are in green color. So actually you have deep veins and you have superficial veins. Deep veins, they run along with arteries and they have the same names. And superficial veins, they close to the surface of your body and they have different names, right? So whatever in blue over here, that means you have arteries with the same name. So we have dorsal metatarsal vein that form a dorsal venous arch. And then we have anterior tibial vein, right? And so over here, our anterior tibial, we also have a fibular vein, we have posterior tibial vein, right? And posterior tibial vein is formed by well, when small veins come together, right? And so the small veins form bigger veins, right? So we have digital veins, we have our plantar veins, medial and lateral plantar vein, and we have our posterior tibial vein. And posterior tibial vein connects to the fibular vein, connects to anterior tibial vein, becoming popliteal vein, right? So there behind is popliteal, and popliteal then moves through the same adductor hiatus, became femoral vein, and femoral became external iliac, right? Then we have internal iliac over here and common iliac vein. And then this one, our inferior vena cava. Now we also have superficial veins. So on the medial side, we have great saphenous vein, right? And on the posterior side, we have this one, small saphenous vein. So those are superficial veins. Okay, now we need also, we need to collect blood from your, kidneys and, so on, right? So here's our, from low extremity, we have external iliac, and this one is internal iliac over here. When they come together, they form common iliac, and then this huge blood vessel over here is inferior vena cava, and you can see it's collect blood from renal veins, right, from hepatic veins, from a liver, and then it moves up towards the heart. Right? So over here we have renal veins, we have common iliac, external iliac, internal iliac veins. But you can see on this picture, okay, we have hepatic veins, so it means blood returns from liver, right? We have renal veins, blood returns from kidneys. We have common iliac vein, blood returns from your low extremities. Internal iliac blood returns from your pelvic organs, but you also have stomach, you have spleen, you have small and large intestine. Well, where that blood is, how that blood returns back to the venous circulation. And this is, actually right there. So I'm gonna skip and I'm go to this picture first to show you that actually from your stomach, from spleen, from small and large intestine, the blood returns back through the mesenteric vein. So we have our inferior mesenteric vein, we have superior mesenteric vein, we have our gastric veins, we have splenic veins. So you see they all in blue. So that means they do have corresponding arteries. But the difference is instead of taking this blood directly to inferior vena cava, they take this blood first to your liver. So actually when you digest your food, right, the food is absorbed in those capillaries and through inferior mesenteric, superior mesenteric, splenic, gastric veins, blood full of or rich in nutrients gonna flow to your liver first, okay? And this blood vessels that deliver this venous blood from your digestive organs to your liver is called hepatic portal vein, hepatic portal vein. And then, you know, from liver through the hepatic vein, this blood returns back to inferior vena cava. Now over here we can see how we collect blood from muscles and skin of your head and face. So this is superficial temporal vein, this is facial vein, and it all collects to the internal jugular, right? I'm sorry. Okay, hold on a second. Yeah, so this collects actually to internal jugular, but some of this blood also collects by through the external jugular. So internal jugular is really huge one. Internal jugular is a huge blood vessel. External jugular is smaller blood vessel because lots of blood, even from your face and a head, returns back through internal jugular. And you know, this one over here is actually the blood coming back from the brain. But, and you know, despite this fact that we don't have this, you know, like when all this external blood vessel goes through external jugular and from your brain you go through internal, just remember that through internal jugular, vertebral, and external jugular, right, through all these three blood vessels, external jugular, vertebral vein, and internal jugular vein, blood is collected from the head, brain, head, face, and neck region, right, back to the brachiocephalic vein. So here's our brachiocephalic vein. And when brachiocephalic vein fuses with internal jugular, it became, when subclavian vein fuses with internal jugular, you have a brachiocephalic vein. And brachiocephalic vein to superior vena cava or cava, and then back to the heart. Now this is how we return blood from the brain. Now, inside this cranial cavity, we have veins, but we call them sinuses. Just because they a little bit different, they have a thinner wall and they more like flat blood vessels, so we call them sinuses. So we have superior sagittal sinus, we have inferior sagittal sinus, transverse sinus, a sigmoid sinus that look like S, and cavernous sinus. So all the sinuses pick up blood from the brain and carry it inside internal jugular vein. And you remember the internal jugular vein over here, right? So here's our internal jugular vein. Okay. Yes. So here's our internal jugular vein that connects, right? Come together with subclavian vein, become brachiocephalic vein. Okay, so that's, now we're gonna bring blood back from our upper limb, right? And we're gonna start with digital veins, superficial and deep palmar venous arches, right? So remember everything in blue, that means you have the same artery. So we have palmar arch, but now it's a venous arch, superficial, and over here we have deep, we have digital veins, and we have actually, if you look over here, you see this not so bright blood vessels, those are deep veins. So on the radial side, we have radial vein. on the ulna side, we have ulna vein, and radial and ulna form brachial vein, axillary vein, subclavian, right, and then brachiocephalic vein and superior vena cava. But we actually have lots of superficial veins over here, and some of them we need to know their names. So let's look over here. Now, this is kind of your body, right? That is a body. So the one that is more medial, right, close to your body is basilic vein. I remember body start with B and basilic with B, so that's your basilic vein right there, right? And then more lateral is a cephalic vein. So here's a cephalic vein. Basilic and cephalic vein, that actually has anastomosis over here or connection, and this is called median cubital vein. And this vein, another superficial vein over here, median antebrachial vein. So this is antecubital region, remember, and this is cubital vein. This is antebrachial region, and this is antebrachial vein. So they all superficial, and you can see that they bring blood to your deep veins. So basilic vein fuses with axillary vein, so it's bring blood to axillary vein, and cephalic, it's actually to subclavian. Right. There is another vein over here called a zygosphate. So a zygosphate vein brings blood from inferior part of the body, but it brings it to the superior vena cava. Now, everything like everything from a low part of your body, right below your heart, you would say, right? So like in your abdominal area, in your thigh and legs and feet, all this blood is collected by veins and carries towards the inferior vena cava, and plus like from your digestive organs, from your liver, and through inferior vena cava to the heart. But there is one alternative route as well through this zygosphate vein that brings blood to the superior vena cava. And overall, it all ends up on in the right atrium, right? Because right side of the heart is receiving right atrium is a receiving chamber for deoxygenated blood from systemic circulation. So we already covered this diagram, and yeah, so the very last slide over here is about our hepatic portal systems that we mentioned a little bit, right? So this is actually this one. So when as already mentioned before, right, when your food goes to your stomach, right, you digest it, and then, well, not so much in the stomach, you start your digestion, then it goes to small intestine and you absorb it, you continue digesting it and you absorb it. Absorb food means those nutrients gonna move from your GI tract to your blood, right? So they move inside capillaries, and capillaries become smaller veins, right? So those nutrients, right, nutrients from your GI tract move inside these blood vessels, and you're gonna carry this blood rich in nutrients to your liver first, and liver will process it. So you will, store some nutrients in your liver. Your liver also gonna clean your blood, and get rid of maybe some toxins, right? But you're gonna bring this blood from your GI tract to your liver through what is called hepatic portal system. And the next diagram over here is our hepatic portal system. So pretty much, let's see what it has over here. So here's your arterial blood. right? And you deliver your arterial blood to your stomach and to your intestine, right? Because your stomach, your intestine made of cells, so you do need oxygen, you do need nutrients. And, you know, the arteries became smaller and smaller, blood vessel became capillaries over here, right? And then, so imagine you have your, you know, over here, your stomach, your small intestine, your large intestine covered by these capillaries. So that's, you know, let's say this is your, you know, GI tract covered by these capillaries. Now you deliver oxygen and nutrients to your GI tract, but at the same time from GI tract, you're gonna pick up nutrients, right? And toxins. Because yeah, we do have some toxins in our food. For example, alcohol. if you drink wine or beer, so that's a toxins in your drink. So all these nutrients and toxins will be absorbed to these capillaries, and then capillaries fuse into larger vessels, and they become the hepatic portal vein. Now, hepatic portal vein brings blood to the liver. Inside liver, it will split into capillaries again, right over here. So it will be a second capillary bed. So we have first capillary bed and we have second capillary bed. And over here, nutrients and toxins will be moved from capillaries to your liver, and those liver cells, hepatocytes, that either process, store those nutrients, get rid of the toxins, and you know, some nutrients will go back over there, right? But then you collect all this blood through now hepatic vein to the inferior vena cava, to the venous blood, right? So you bring oxygenated blood to your digestive organs. You form the first capillary bed. Then you pick up nutrients within those capillaries. You carry everything to the liver. Liver taking care of your nutrients and toxins, clean your blood. Some nutrients are stored, some nutrients stay right inside the blood because you need to deliver it to the rest of your body, and then through the hepatic vein follows to your heart, and you know, from the heart to your lungs, from lungs back to the heart, and to you know, to every part of your body. Right, this is what hepatic portal system is. The important thing here is to remember that this vein that carry blood from GI tract to liver is called hepatic portal vein, and the vein that carry blood from liver to inferior vena cava is called hepatic vein. Okay, so that's it for this lecture. I do have physiology part that I will record a separate lecture covering physiology part, right? So that's it for today. Thank you for watching, and I hope it was helpful.